Buenos días para todos, muchísimas gracias por su asistencia. Vamos a esperar 5 minutos más para darle inicio al evento. Buenos días para todos, daremos inicio a nuestro evento en 5 minutos. Muchas gracias por su asistencia. Buenos días para todos, mucho gusto. Mi nombre es Karen Cavies, ingeniera comercial para Barichim de Colombia. Agradecemos su presencia el día de hoy acá para nuestro tercer Knowledge Experience, en el cual estamos realizando en alianza junto con Bicoma, empresa inglesa de más de 50 años de experiencia en el mercado para la atención, equipos para la atención de derrames. Thank you so much for your attendance. We're glad that you're here, and welcome to our third knowledge experience about the effective use of skimmers to upgrade and retrofit existing petrochemical facilities. We are in partnership with Bicoma, and we have an international guest that is Peter, that I'm going to present later on. Thank you so much for your attendance. Para las personas que deseen las memorias en español que vamos a compartir el día de hoy, en la parte superior de la pantalla pueden ver la opción de preguntas para que por favor nos compartan sus correos electrónicos y asimismo nosotros poderles compartir la presentación en español. La presentación tendrá dos momentos, el evento tendrá dos momentos. El primero a cargo de Peter, quien nos compartirá parte de su conocimiento. Y la segunda parte estará a cargo del equipo de Barichem de Colombia, contándoles esos casos de éxito que hemos tenido a nivel internacional sobre el uso efectivo de los skimmers para mejorar las facilidades existentes y nuevas petroquímicas en la industria. Muchísimas gracias por todo. Vuelvo a repetir. Si tienen alguna pregunta o si nos desean compartir su correo para compartirles las memorias en español, en la parte superior derecha se encuentra la opción de las preguntas. Agradecemos a cada uno de ustedes nuevamente por su asistencia. Esperamos que sea un espacio en el cual podamos compartir ese conocimiento que tenemos nosotros y que en estos 25 años hemos adquirido junto con cada uno de ustedes. Thank you so much for your attendance. If you have any questions, you can put it on questions and answers button that it's up to the screen. And if you want that we share the Spanish version presentation with you, just please share with us your email and we send it to you. So thank you, and we can start the event now. So I'm going to start with the agenda. So I already said the welcome and greetings from the event, and next one is going to talk Peter. I'm going to give you a brief presentation about him. So Peter graduated in 2007 with a Bachelor of Education honors degree from the University of Exeter. Following graduation, Peter worked in various roles within industry and the public sector as a teaching and trainer in both in UK and New Zealand. In 2010, Peter joined Bycoma International Limited as the lead trainer for both on-site equipment operation, spill response training, and equipment specification writing. During his time at Bycoma, Peter has led the tender management, a key bid submission team, and is now also the geographic territory manager for the Americas and the key account from the major international oil companies who conduct regular business with Bycoma. Vamos a empezar con la presentación de Peter. Peter se graduó en el 2017 con una licenciatura en educación con honores de la Universidad de Exeter. Después de graduarse, Peter trabajó en varios puestos dentro de la industria en el sector público como profesional de enseñanza y formador, tanto en el Reino Unido como en Nueva Zelanda. Para el 2010, Peter se incorporó para Bycoma International Limited como instructor principal para la operación de equipos en sitio, la capacidad de respuesta de derrames y la redacción de especificaciones de equipos. Durante el tiempo que ha llevado en Bycoma, Peter ha liderado el equipo de administración de licitaciones y presentación de ofertas claves. Ahora es el gerente de territorio geográfico para América y las cuentas claves de las principales compañías petroleras internacionales que realizan negocios habitualmente con Bycoma, una de ellas, Barichem de Colombia. So Peter, thank you so much for your here, and we all yours.
Okay. Right. Okay, well, good morning, everybody. Good afternoon, if anybody is tuning in from the UK, where I'm currently sitting. So thank you, Karen, for the introduction. It sounded just as good in Spanish. So and thank you for your time today, everyone attending. So yes, today's discussion is going to be the effective use of skimmers and to retrofit or upgrade existing petrochemical facilities. So it's quite focused, but hopefully it should be of interest to each of you, and we can explain some of the areas that Bycoma are able to provide solutions here. So I will hopefully not speed up, because I do appreciate we have majority Spanish speakers, but there are some visitors from North America and Canada, USA and Canada. So, okay, a brief summary of the problem. So petrochemical facilities are designed and built with a maximum throughput in mind. So this is generally number of barrels per day that the facility can process. And a key part of the process is separating the oil from the wastewater that's used in various steps of the process, whether it's cracking, cutting, dilution, or what have you. And the water separation can be done in a number of different ways, using dedicated separators or in separation ponds or pits, whatever the process requires. Essentially, for the separation of the oil and the water to be successful, it does need time so that two clearly defined layers can be formed, oil resting on top of the water. So a common problem that we see all over the world is that due to population growth and increased hydrocarbon demand, an existing facility that is built, it's forced to work at the top end of its operational level. So this leaves less time for water separation and results in larger quantities of oil being present in the wastewater system. So we see this as many things, more people requiring hydrocarbons, and more demand on the facility. If it's designed to run at 100,000 barrels per day, for example, it's really pushed to the limits. Very rarely does a facility get chance to work way below its limits, so therefore with extra time. So that is the problem. One of the other problems that we do see as well, if a facility is working to its operational limits, is the fact that populations are getting bigger and people are always moving closer and closer to the refineries or to the petrochemical facilities, which, as we know, because of the nature of the products, they can smell of hydrocarbons. You can get the VOC gases in the air. With populations moving closer, it's a way of managing the volatile gases in the air that could be near housing estates or villages, what have you. So next slide, please, Karen. So there are two solutions for excessive oil and water buildup and not giving the facility enough time. And the first solution that I have put is very simple: to build a new refinery or build a new petrochemical facility, which is great, okay, build a new one and everybody's happy. As we all know, this isn't viable because petrochemical facilities cost an awful lot of money to manufacture. That's the facility themselves, let alone the infrastructure that needs to supply that refinery or petrochemical plant. So that was put there as an example, as a solution, but it's not a viable solution for people to spring up and build a new refinery every week. So the second solution is much more attainable and achievable, and that is to upgrade or to retrofit the existing facility so that it is capable of separating the higher amounts of oil and water within its process. So by helping that system along, making it more efficient, making it more accurate, then the whole facility can process at its higher end of its requirements. So these are the two solutions, but we will obviously be focusing on solution 2. Next slide, please, Karen. So there are different options that we can have, and today we'll be focusing on the patented Vicoma T-disc skimmer. So for those people who do not know Vicoma very well, Vicoma is a specialist in manufacturing oil skimmers and containment equipment, and the majority of the equipment goes into marine oil spills, so oil spills in the sea or the ocean. The T-disc skimmers, however, are very different, and they are specifically designed for industrial applications, so very different to a marine skimmer. And throughout some of the technical detail we'll be sharing during the knowledge experience, hopefully you'll get to see how they look and are built very differently to the marine skimmers. The process still remains the same. The oil sticks to a disc that rotates through the oil and water. The water does not stick to the disc, and then the scrapers remove that oil to a place where it is needed or is need to be concentrated. So it works in a similar way, but the details in the following slides will show just how the industrial skimmers are different to the marine skimmers. Okay, next slide, please. So the benefits we have for upgrading and retrofitting an existing facility with industrial skimmers, large cost savings. You know, it's for a short outlay of cash at the start of the project. These things will, you know, they last for an awful long time, and they increase the efficiency of the system. Because of the efficiencies, because they select only the oil and not the water, the oil is much more useful. It has a lower free water content, and it can be reused if filtered. So once set up and running, these systems are designed to be worked as part of the process. So they can be left unattended. They do not need a physical operator to stand by them and use them. And that goes with the safety alarms as well, which we'll cover a bit later on. They are relatively quick to set up, so you do not need to close the petrochemical facility to install one of these things. You know, it's much like a bolt-on or a drop-in system that can be added to an existing pond or separator. So it doesn't require that separator to be decommissioned and taken apart for this to be added. I covered earlier on they're highly efficient. We'll talk about some of the recovery rates for oil only, and obviously we've covered the minimum downtime. So as most facilities will have planned routine maintenance throughout the year over a given date, these systems can be installed within that time frame very easily. Because of the high efficiency and the relative low cost for the job that they do, it's a very quick investment payback. That hopefully you will see in some of the case studies that we can discover later on. And yeah, also the systems, the skimmers, they are very open to the ranges of oils that they can recover. So these skimming systems have been successfully installed in crude oil processing facilities, right the way down to some very light fish oils, to kerosenes. You know, so they don't just target one particular type of oil. Okay, Karen, next slide, please. So from this point, the presentation will start to focus on the different kinds of oil water separation techniques, and then the ways that the systems have been applied to each of those. So you will see a pattern with the look of the skimmers, but with each different style of separation, you'll see the requirements on the physical skimmer themselves change. So we'll start off looking at settling ponds, evaporation ponds, legacy pits. They have lots of different names, but these are the large outdoor settling ponds or lagoons where a high volume of water and oil is placed for a given amount of time to allow those two clear layers to form and separate. Next slide, please, Karen. So this is a small water outlet, and you'll see there is a floating skimmer placed in. So it's very common when you're dealing with separation of oils and waters to have an overflow lip where the oil sits on the top, and when the level of the liquid gets to a certain layer, it would flow over the top and decant onto, you know, into a collection area. So this is a relatively small outdoor pit. And this skimmer is called a floating T6 skimmer. It is called a T6 because the disc has a T-shaped profile on the end, and the 6 runs basically at the number of cubic meters per hour that skimmer can recover. So we're looking at 6,000 liters per hour, or 6 tons per hour is a quite a simple way of thinking about it. Excuse me. Next slide, please, Karen. Okay, and here's another version. This is called the T9 skimmer. So as you'll see, slightly larger, and because it has a few more discs, it can recover more oil. And yet again, placed in an outdoor lagoon where the oil and water is left to settle. Now, the reason we started off focusing on the ponds or pits or whatever they're called in your facility is these are not controlled with the level of fluid that runs into them. So for example, the water level or the fluid level within these pits and ponds, depending on how much has been pumped in, can vary. It's not like a dedicated oil water separator which will have a constant level. This system that you can see on the slide in front of us, if you look closely around that pit, you'll see a week or two before there was high rainfall and the pond or the pit had overflowed the edges. There was still secondary bunding around, but it's a good example to show that the levels of liquid in this pond will increase or decrease. That could be the time of year or the amount of work going through the process. So this floating skimmer will always sit on the surface and it will always target the oil. An interesting point is that this skimming system, when placed in the pit only a few days before, the oil create was about 2 or 3 inches thick across the entire surface of the pond. So within 2 days, all of that surface oil had been removed, and then only new oil that enters the pit was getting drawn into the skimmer. I say that because a pit that has, or a pond that has a thick oil surface across can cause problems for local wildlife. The birds do fly to these things for seeing them as a water source. And also those volatile gases that I mentioned earlier on, if they are just sat cooking in the sunshine, then the air around these pits, you will be able to smell the hydrocarbons. That's why, generally speaking, the separation ponds or the legacy pits, whatever you want to call them, are at the other end of the facility to the offices. They are generally far away so that the smells do not impact the people who are working on the site. That is a very interesting, well, very vital point, because if these ponds are far away and not in the main throughput of the site, they still need to have the safety mechanisms in place to automatically shut down the system if there's any mistakes, any errors. It's very worth noting that just because the separator ponds are a long way away, they should be able to be remotely operated for site safety. So yeah, next slide please, Karen. Yet again, I'm not sure. I think this is actually a different photo to the one earlier on, but it is another floating T9 skimming system, and you can see that the surface of this pit is clear of large clumps of oil, and therefore the volatile gases in the air, the vapors, are reduced massively. Now these are reduced very, very quickly, which is a good thing if populations are starting to move closer and live closer to the refineries, to the petrochemical plants. They won't be having that fuel forecourt smell in the air continually. So these systems are designed to run slowly and smoothly, 24 hours a day, 7 days a week, and every day of the year. So the yearly maintenance for these would be within 2 hours, maybe, a check over to check the pump or check the scrapers on the discs. They're not designed to expect high levels of maintenance on a regular basis. It simply doesn't happen. So yeah, next slide please, Karen. Fantastic. So we've briefly talked about the skimming systems, and that works on the same principle as a marine oil skimmer. The disc travels into the oil and water, the oil sticks to the disc, the water does not, and then the disc is rotated through the scrapers and the oil comes off. Normally, if this was a marine oil spill or in a river, because that spill could happen anywhere, it's very common to use diesel engines that drive a hydraulic system. Within the industrial facilities, we're very lucky because we know where the oil and water needs to be separated, in the separators, in the ponds, in the pits. So a dedicated power pack can be plugged into the site supply. So this power pack, as an example, is an electro-hydraulic power pack, and it has many safety features built into it for its specific operation within a refinery or a petrochemical plant. So some of these features, for example, would be an ATEX or class zoned motor for driving, a larger hydraulic reservoir so that the hydraulic oil does not heat up and create any flash risks. And in some of these photos, you might see some of the dials or the pressure bottles that are emergency shut-off valves. So if an unexpected heat is detected, for example, in the transfer pump, it might simulate that there has been a broken seal in the pump and friction could be generated. So friction would cause heat. So that pressure bottle would identify that and shut off the systems before any heat was generated, any spark was given out, and any explosions happen. And just for good measure, a thing that makes these look slightly different is the sun canopy. There is a roof, because it is designed to sit in the open air 365 days a year, and ideally you don't want things heating up to have a hot surface. Something as simple as the sun canopy can generally help to keep all of these elements cool, to prevent that flash point and that hot surface. Next slide, please. So I'd included some of the general arrangement drawings within this presentation. It might be quite difficult for everyone to fully see and pick up all the detail now, but this is the floating T6. So as you can see, there are 2 discs, and some of the things that do make these systems very different, whether it's a T6, the T9, or even the largest T14, would be, first of all, the materials that the systems are made from. So these systems are made from a number of different materials depending on the chemical composition of the pond or the pit that they're in. So very common for stainless steel 316. However, and it is often happens, there are caustics, high levels of caustics, fluorides, sulfides, then we can design and build the skimmer out of different types of metal, so hardened steels, duplex, super duplex. That is part of the engineering towards these systems, because if we find out that these are in a sour water or a high chloride solution, by simply changing the metal that it is manufactured from, could mean that the system lasts for many years before the aggressive substances start to damage it. There was a refinery in the Côte d'Ivoire, Ivory Coast, in West Africa, that were using a marine skimmer in their pits, their pond, and within every 2 to 3 months, it was being completely eaten and corroded by the acids. So, you know, it just goes to show a marine skimmer can skim oil, but it can't always tolerate the aggressive substances that are in the refining or the petrochemical process. So this is the T6, the smallest unit. You'll see it is hydraulically driven, but it does not have a transfer pump. So this would normally have a freestanding transfer pump in a company. So next slide, please, Karen. Okay, here we have the T9, so slightly larger. It's designed to cover more oil, to recover more oil, and you may see, if your screen is big enough, that this unit has an onboard transfer pump. So the difference with this is because it is covering a larger recovery rate of oil, it then relies on the pump to drive the oil, to push the oil, instead of sucking the oil from the side of the pond. So the T9 has a higher delivery rate because the pump is not working as hard. Depending on the customer's requirements, these pumps do change. Sometimes there is a requirement for it only to pump the oil a short distance. Other times it's a much increased distance. So yet again, that is captured within the document package and the document requirements by the engineers who design the system. So we appreciate that petrochemical facilities all over the world are different. They deal with different oils and different products. They have to transport that oil to different destinations. So therefore the systems need to be quite bespoke to suit their exact area of operation. And next slide, please. And this is the largest type of floating skimmer that we do. So this is the T14. So this can recover up to 14,000 litres per hour. So it's a very large amount of surface oil that can be recovered. And it also very accurately. So I started off mentioning the high efficiencies. These skimmers will collect between 95 and 98% oil, less than 5%, between 2 and 5% free water. So the conventional methods for skimming that oil, like I mentioned, the overflow technique, they rely on an operator to accurately operate the overflow valve, and you know, the oil to only flow first. If the water is captured in that surface layer, then that goes as well, and it all adds to the oil-water ratio. So the T14 can do 14 cubic meters or 14,000 liters of almost pure oil per hour. And quite often when these systems have been installed, that oil water has such a low water level that the oil is, it has a value, it has a use, and it can often be used to drive the slop system of the petrochemical facility with very little extra process. So by targeting these high amounts of oil and leaving the water alone, it then in the first phase of interception, the first oil water separation, it drastically takes the pressure off the rest of the process downstream from that. So because lots of facilities, you have a series of ponds and pits where the water transfers from one pond to the other, getting cleaner as it goes, until the final ponds it relies on coalescent filters, it's reed bed technology sometimes. If you have too much oil pass into those, the filters become jammed, the reeds will die, the system is stopped. By removing the high volumes of oil at the very beginning, then it takes the pressure off the rest of that system. So it's it is very effective for increasing the throughput in the whole system. Next slide, please, Karen. Okay, just an example of the power packs. Depending on the areas of operation, the number of skimmers they are designed to drive, or the site safety regulations, these power packs do change, much like the skimmers. So essentially, if it's class zone classifications, or if it's ATEX, it doesn't really matter to us what classification body the facility uses. The equipment can be built with its area of operation in mind and comes with its documentation package. So what that would mean is, if due to a number of chemicals the facility is dealing with, the area is very volatile and explosive, then it could be an ATEX Zone 1 or Zone 0 skimmer, ATEX Zone 2 or Zone 1 power pack and pump. Essentially, we capture all of these details at the initial inquiry phase, and all of the design work and the engineering work is done with the exact facility in mind. So these systems wouldn't work with a off-the-shelf catalogue product, because you know, one facility might need an ATEX Zone 0. You know, another system may not require it. It may only require ATEX Zone 2. So they are very bespoke, but it's our in-house design engineering team are specialists at this. So next slide, please. Okay, I put this in. This is a floating T9 skimmer, and just to show that the way some of these are changing. So this is the an oil trap before the oil water solution enters a 3 bay API separator. This is in Singapore, and the reason I wanted to put this in, it shows the development in modern times. So these skimmers are left unattended. They don't need an operator, so they are run with timers. And the interesting thing about this project is that along with a power pack, there are solar panel cells that are installed. So throughout the day, the green energy, the solar energy, is captured, stored as in battery packs, and those battery packs help to power the electrohydraulic power pack for the skimmer. So the power consumption, the power requirement, sorry, for this system is massively reduced, because it is harvesting the daylight, and therefore the running costs are even lower for the skimmer. It's a very new project. It's currently being installed, but it's a good way of showing that now that solar technology is developing, these are being used to run process equipment within some of the petrochemical facilities. So I wanted to put this one in just to sort of say that there are developments out there for environmental, you know, in case the environmental legislation is increasing in your particular facility. You know, these things don't just have to be plugged in and sucking power from the net from the grid, when the solar options are there to assist. Next slide, please. So I've included the technical data sheets for the skimmers. I've shown some of the images, and I'm assuming with your access to the presentations in English or Spanish, anyone watching this will be able to then look at the data sheets to get a rough idea. Okay, if we need only a small skimmer because the pond is relatively small, then you may need a floating T6 skimmer. Likewise, Karen, if you can flip through, we should then start to move to the T9 and then to the T14. This should help just, you know, give a bit of insight, a bit of a view as to the types, the sizes of the skimmers and the amount that they can recover. What I would say is if anybody attending this knowledge experience thinks that the industrial skimmers could assist in upgrading their facility, you don't need to make a decision on technical specifications shared today. If you reach out to Varichem or to myself or to the regional representatives of ICOMA, if you are not in Colombia, these items are put forward as a very tailored package. So we could provide a site data sheet to understand which chemicals are present, how much oil needs to be removed, if the water level changes, how far the oil needs to be pumped. So all of these things are captured to make sure that the right equipment is specified at the start. And yeah, so it's but these are just a useful point to look at. And next slide, please. Okay, and here's the same for the power pack. Like I mentioned, if you happen to go for a smaller unit and you don't require as much power, then these vary in size and shape and consumptions as well. Next slide, please. So we do have some case studies. Karen, can I just ask, is Hader going through the case studies, or is that?
Yes.
Okay, so I'll have a drink of my coffee and come back to you when Hader is done.
Go ahead.
Thank you.
Yes, for the next part we have Hader. He is a commercial manager of Varichem of Colombia. He's a chemical engineer from the Universidad America, with a specialization in senior management, basic training in business coaching, with more than 13 years of experience in the industry. And he has worked as a drilling fluids engineer, operation coordinator, and commercial director. Hader es el gerente comercial para Varichem de Colombia, es ingeniero químico de la Universidad de América, con una especialización en alta gerencia, formación básica en coaching empresarial, con más de 13 años de experiencia en la industria. Ha trabajado como ingeniero de fluidos de perforación, coordinador de operaciones y director comercial. Hader sigue adelante. Vuelvo a hacer el anuncio para las personas que requieran las memorias en español. Por favor, en la parte de las preguntas nos pueden compartir sus correos electrónicos. De igual manera, si tienen alguna duda o pregunta, la pueden realizar tanto en español o en inglés, para al final del evento poder hacer una sesión de preguntas y respuestas para aclarar todas sus dudas. For the person that wants have some questions, so the link up to the screen, it's able for any question that you have. On the final part of this session, we will answer all your questions. So next one, Hader, go ahead. Thank you for coming. This part is going to be in Spanish, so the person who wants this one is going to present it in English, but we are going to explain it in Spanish.
Ok, muchas gracias, Karen. Y muy buenos días para todos los participantes. De acuerdo a toda la información que nos ha dado Peter, pues queremos compartir también con ustedes algunos casos de éxito en la que hemos implementado la tecnología a través de Vicoma, donde logramos un proceso digamos que de conexión con el cliente de acuerdo a las necesidades y a esos requerimientos técnicos que se derivan pues de la operación de cada uno de los escenarios que tienen nuestros aliados. Uno de estos casos es una implementación donde instalamos dos Skimmers T14 en los separadores de API. Estos separadores, digamos, en dos de sus divisiones tienen varias concentraciones de diferentes productos de diferente tipo de aceite y de crudo, con más o menos unas 50 centistocks de viscosidad. Esto lo que hace, le genera algún tipo de problema porque digamos que en estos tipos de separadores se necesita o se requiere tener el estándar, pues, o por lo menos tener caracterizado el tipo de fluido que está llegando a contenerse allí. ¿Qué es lo que pasa? Que esa variedad de productos, se está llegando producto crudo de los procesos, está llegando también crudo que se tienen los tanques de almacenamiento y estaba llegando también algunos productos secundarios dentro del mismo tanque, del mismo separado. Al ser también al cielo abierto, pues en esta área donde estaba situado el separador, donde está situada la refinería, pues ocurren lluvias torrenciales y pues lo que hacía era saturar las descargas o las líneas de descarga de la tubería desnatadora que tenían instalada en su momento. Siguiente, por favor. Una vez nosotros tenemos pues ya identificado el tipo de problema, lo que se hace es sugerir la tecnología que más puede, digamos que, cumplir o satisfacer esas necesidades. No solamente es en cuanto al problema o a la solución que se debe brindar, sino también se aprovecha para tener ese background y lograr optimizar un poco los procesos del cliente. En este momento nosotros digamos que tenemos la oportunidad de identificar esos procesos de mejora y poder adaptar esos objetivos del cliente. En este caso, los objetivos pues al tener solamente la tubería desnatadora, pues eso requiere algunos procesos operativos, eso requiere algunas paradas y algunas intervenciones por medio de operarios. Y pues el cliente nos dice, "No, yo necesito también que la operación se haga de manera continua". Lo otro que se requiere por parte del cliente, pues es que el porcentaje de agua que debe estar dentro del tanque del separador debe ser por lo menos del 2%. Si ellos están en este momento teniendo problemas de saturación de agua por lluvias torrenciales, pues en la tubería desnatadora claramente pues no le está dando ese porcentaje del BSW que necesita su líquido. Y pues deben tener un skimmer pues de alta eficiencia para lograr pues controlar los volúmenes que se manejan ahí. Con esos objetivos y con ese problema pues que se tiene técnicamente, con el equipo técnico, pues con todo el grupo de ingeniería, se propone la instalación de este tipo de skimmer industriales. Son completamente en acero inoxidable, son el T14, y lo que tiene es que logramos una recuperación por debajo del 2% de agua en todo el fluido que recolecta, y pues tiene toda la posibilidad pues de manejar sus caudales y los fluidos que ellos manejan, incluyendo pues los productos secundarios que se encontraban allí en el fluido. Que durante esta operación continua pues dio como resultado que durante el año pues el cliente logró recolectar de aceite un poco más de 2.000 toneladas de aceite recuperado, y pues obviamente con muy bajos costos de mantenimiento. Siguiente, por favor. Un segundo caso es la instalación de un T9. Este es un caso, digamos que algo particular, este es en un sumidero. Y la presencia, digamos, el fluido que estaba en este sumidero era prácticamente dominado por aceite lubricante, aceites hidráulicos, y pues el sumidero tenía digamos que varias situaciones ahí. operacionales y también de seguridad. Una, pues que al tener este sumidero digamos que el nivel del suelo, está ubicado en una área de alto tráfico de vehículos, de alto tráfico de carga pesada, y pues esto lo que hacía era que les aumentaba un poco el riesgo para que se empezaran a generar algún tipo de leaks o de lixiviados o de algo de ultrafiltración ahí de estos aceites hacia el suelo, ¿m? O hacia algún tipo de cuerpos de agua que pudiera haber alrededor. Y pues obviamente al ser es un sumidero que estaba a 10 metros por debajo del nivel del suelo, y pues eso es lo que requiere, digamos que es un esfuerzo adicional del equipo para lograr compensar ese cabezal de la altura y lograr tener el fluido recuperado en superficie. Hacemos, por favor. Siguiente, por favor. El, el problema, pues, uno de los objetivos que se requiere, pues, de la instalación del equipo es que debe tener una bomba incluida. Si quieres, le das la anterior, Karen, por favor. Y esto pues lo que implica es que esa bomba pues debe tener la suficiente potencia para tener ese cabezal, y un segundo requerimiento es que la descarga o pues sí, todo el fluido recolectado se debe trasegar directamente hacia un camión cisterna. O sea, arriba en superficie pues no cuentan con algún tipo de facilidad para poder almacenar temporalmente el fluido, entonces se debe coordinar pues con el tanque. El segundo requerimiento pues que debe ser un skimmer pues de alta capacidad, y debe tener por lo menos un 2% la recolección de agua, pues, todo el fluido que se recolecta. La solución que se le da pues al cliente es la instalación de un skimmer T9, como ustedes lo están viendo ahí en la gráfica. Está pues dentro del tanque sumidero. Es lo que hace es nivelarse de acuerdo al nivel de capacidad que esté usando el tanque, y adicional a eso, pues tiene instalada la bomba en el mismo pack pues del skimmer, para poder trasegar todo el fluido al, al camión cisterna. Obviamente el requerimiento un poco más exigente, pues que debe ser completamente intrínsecamente seguro. El, 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 el equipo debe pues tener todos sus controles de gases, y debe pues tener la capacidad de poder trabajar y operar sin ningún riesgo en estas zonas clasificadas y en estas áreas de tanques confinados. Siguiente, por favor. Eso es, digamos que de lo que hemos visto con Peter, tenemos esos dos casos de éxito. Adicionalmente, este T9 se fabricó de una manera modular. Las claraboyas, pues, o las entradas del tanque sumidero, pues, eran bastante limitadas. Lo que se hizo fue em, se hizo un skimmer diseñado para que se pudiera desensamblar, pues, ingresarlo al sumidero y volverlo a ensamblar ahí mismo adentro. Muchas gracias.
Muchas gracias a ti. And we can keep going with Peter. Hope that you copy We're cool, so we can keep going with you, Peter.
Okay, fantastic. Thank you, Hade. So, I mean, up until now, the equipment was floating skimmers with electrohydraulic power packs, and quite a simple separation method, which is a pond or a pit. You leave the product in there, it forms 2 layers, and then you can switch on your skimmer and move the oil. This next section is where the industrial skimmers becomes more focused. So, for example, the oil water separators that are built as part of a petrochemical facility, they are dedicated pieces of equipment, the separators, and they do have a process to themselves. So, for example, API separators, CPI, the corrugated plates, chain and flights, where the solution, the oil water mixture, is left to settle but remove the sludge from the base of the separator and drive the surface oil to a collection area. Now, these are existing parts of the infrastructure for the refinery or for the facility, and they fall into that classic thing that I said earlier about they work perfectly well under normal operation levels and under the operational level that the site is designed to. When the site is pushed to its limit to work at high levels, that's when these separators have a higher throughput, so a larger volume of oil and water mixture, and therefore they have less time to separate the two. So this is where the retrofit or the upgrade of a refinery or petrochemical facility is really noticed, and the benefits are huge when these existing separators are upgraded, basically. So next slide, please, Karen, and I'll explain about these. So this is a very simple photo of a freestanding oil water separator. It's quite a small unit, this one. It's probably the same sort of footprint as a 20-foot container. But generally, the separators in question are much larger. Some of the other photos will show that. So it can be freestanding, as in built on top of a concrete base, or it could be a separator that is built into the ground. So next slide, please. Okay, so here we have an API separator. This is actually what we call a dual or a double bay separator. So you can see the wall traveling down the middle. That is a vertical wall that separates each of the bays. And within this separator, the oil floats to the surface, the sludge sinks to the base, and they are both removed from dedicated ports. Now, this API has been retrofitted already with what I would call a bridge system. So the skimmer is held in position at the water surface by that fixed stainless steel bridge, and the water layer remains at a constant level. So there is no high liquid level or low liquid level. The water level is constant, and therefore there is always an interaction between the discs and the liquid layer. So these are T14s, and as you can see, this double API separator now has the capacity to take 28 cubic meters, 28,000 litres per hour of pure oil from these two bays. So that is a large amount of oil to be taken out, and that drastically reduces the amount of oil in the next system along. So next slide, please. Okay, here's a close-up of one of the T14s working. You see this is a reasonable thickness crude oil, and what this shows is the discs running through the oil. I mentioned earlier on, these are called T discs, so they have that T profile on the top that keeps the surface tension of the oil and encourages more oil to be dragged towards the skimmer recovery unit. It's great when you see them like this. They're working, they are covered in oil, and it is very worth noting that this piece of equipment will be doing this 365 days a year, 24 hours a day. So it's not just switched on for a couple of minutes and has to be supervised. It is a continual operating piece of the process equipment. I talked earlier about the skimmers being designed for their area of operation. So just to go back to that, this is in the heart of an API separator, which is also in the heart of a refinery, not like the ponds or the pits that we talked about, which are far away so that the smells do not annoy everybody. These are right in the middle of a very volatile working environment. So the scrapers need to be made from a very special material because they cannot cause static, they cannot generate heat, and a scraper, which its design principle is to create friction so that the oil is scraped off, but very specialist materials have to be used so that these do not generate excess heat or any static electricity, because you simply can't have that in a refinery. The same goes to be said for the bearings on these rotating discs. They need to be anti-static bearings so that there is no heat generation through 24 hours use, continual use. So things like that need to be addressed by the designers. This isn't just a marine skimmer made of stainless steel. This photo kind of shows it. An existing API separator, there could be a diagram in a few moments which I can refer to, but an existing API separator would normally use something called a C pipe. C meaning letter C, like a crescent, and the C pipe is designed to stay at the water surface level and be rotated around until one lip of that C, this part here, goes below the surface, so that the oil will flow over into the C pipe where it is drained away. I witnessed one of these C pipes in use in a refinery in Sudan, in Africa, and whoever had set the C pipe had not done so very carefully. So the lip of the C pipe was about 50 millimeters under the surface, when the oil layer was 10 millimeters. So there was an awful lot of free water in that system, and it was very easy to look further down the system. In the next API, there was still lots of water, lots of oil. So because this system had not efficiently removed the oil from the first separator. So this T9 system that you're seeing now is delivering 98% oil, less than 2% water, into a closed C pipe. So the C pipe is lifted into a vertical position so that no free water can get in, but only pure oil is being poured into it. So it uses the existing piping, the existing C pipe from the separators, but it drastically increases the efficiency of that C pipe, of the API separator itself. Without stealing Hades slides for later on, when you're talking about retrofitting an existing separator, they are nearly all fitted with C pipes. It's an accurate way of getting the fluid in to be pumped away, but it is non-selective. So this all of a sudden takes the unselective C pipe and turns it into a very efficient selective method of transporting the oil. So yeah, next slide, please, Karen. We should. Here we go. So this is the example. So you have at the top the support structure, the bridge, as I refer to it, and that holds the skimmer cassette in position. So as the discs rotate through, they get hold of the oil, it sticks to the disc, goes down the scrapers and into the skim pipe, the C pipe, the slotted pipe, whatever you wish to call it. This diagram does show how very accurate oil recovery is gathered from a C pipe when it could, if left, gather lots of water. So this is how the bridge systems work. The beauty of this, like we saw in the double API separator earlier, is if you need up to 14 cubic meters of oil recovered an hour, you can have a T14. If, like some of the largest refineries in Saudi Arabia, you need more than that, you can just have one T14 next to another T14, next to another. I think the largest I have heard was 8 bridge systems side by side in a large separator. Next slide, please. So this is just the technical drawing. Anyone who has access to the presentations, whether it be in Spanish or English, will be able to zoom in on this to see. This system does not require a transfer pump. It uses gravity to flow into the C pipe, and then the C pipe would drain from the separator. This actual drawing is from a project in Saudi Arabia, in the Riyadh refinery, I believe, where the bridge was positioned, and it looks quite simple, but the separator design for this is the design used by, I believe, Siemens Water Solutions. And we have lots of these systems built into the existing separators, whether they're manufactured by Suez, Veolia, Siemens, Westtech. There's a whole list of companies who have built oil water separators in the past. And if those systems, those separators are, up to their efficiencies, up to their maximum outputs, then this system can be installed to drastically improve the oil recovery rates. So by quickly removing that oil, you take away the smells because the oil does not spend so long on the surface. And it also allows more surface area for liquids to rise and gather to be then removed away. So next slide, please. Fantastic. So I included this. It may be covered by one of the case studies later, but this drawing just goes to show that existing refineries, they weren't built with disc skimmers in mind. They were built with a process in mind. But then through a whole number of reasons that we have talked about, the skimmers may need to be added to increase efficiency or to increase oil recovery. So these APIs were actually situated quite a long way below ground. So the bridges were built with locating pins, and that could be lowered down into these pits that were below the surface. So I included this because the design packages are done at Vicoma, along with the manufacturing, along with the testing, the factory acceptance tests, the material tests, the documentation packages, because we know that all refineries are built to their original design, and only a versatile system must be used to then match all of the different designs. So yeah, this is just a good example that the 3 bays had to be dropped down, I think 5 or 6 meters to the liquid level in the APIs. Next slide, please. And like I did with the others, there's some technical data for the bridged systems. This will talk about the electrical requirements for the power units, the hydraulic requirements, and also these vary to what the customers actually have on site. So there are places that we have provided these where the site electrical supply is not as reliable as the site pneumatic supply, because they have their own air compression systems, whereas the national grid electrical supply is not as strong. So if the customer decides we would rather have a pneumatic driven system than electrical, it's fine. It's very easy for the design engineers to take that into account. So this would show rough weights and dimensions and requirements, but it must be noted that anybody who may need some of these to upgrade a facility, to retrofit a process plant, they can tell us what they need and that will be achieved. Next slide, please. Okay, am I handing over to Hadair again?
Yes, thank you.
Sir. So, de acuerdo a lo que continuamos acá mirando, ya es otro sistema de instalaciones en las que podemos aplicar los equipos de desnatadores. Este es un caso en el que este tipo de separador, lo que se tiene son diferentes tipos de fluidos, digamos que algunos secundarios, otros tenían presencia de aceite hidráulico, tenía presencia de aceite lubricante, y adicional a eso pues tenía algunos productos secundarios como diésel y crudo. ¿Qué es lo que sucedía con esto? Este separador pues tenía instalado una tubería desnatadora tipo C, y pues todos los desagües, todas las líneas de descargue pues se estaban saturando de agua, y pues estaban teniendo, era más colección de agua que del mismo aceite. Entonces lo que se hace, digamos que ese es el escenario. El escenario, una segunda parte pues era su riesgo operacional, porque no contaban con ningún control para control de gases. Entonces, al no tener el monitoreo constante, pues al ser una zona clasificada como peligrosa, y pues no tener estos controles, pues no se podía permitir el ingreso de ningún tipo de operador para hacer las maniobras que correspondieran con la tubería desnatadora. Entonces, lo que el cliente nos requiere, o aprovechó pues para poder mejorar esta operación. La siguiente, Karen, por favor. Es poder contar con un equipo, que le permitiera, digamos que, reducir esos tiempos de hora hombre, en las que no tuviera que tener pues un ingreso constante en estas zonas de clasificación. Ya tenían un sistema pues instalado, que era esta tubería tipo C, que digamos que les funcionaba muy bien, pero no estaba clasificando pues el tipo de fluido para colectar. Entonces eran dos pilares importantes, dos cambios pues, que se sugirieron. Uno, pues el skimmer que fuéramos a instalar tuviera una caída, una descarga por gravedad, y que esa descarga llegara directamente a las líneas de descarga de la tubería desnatadora del separador. Eso, primera medida. Segundo, pues que tuviera realmente un trabajo de recolección de aceite, que es realmente pues el interés que se tiene en este tipo de operaciones. Entonces instalamos un skimmer T9. También con un puente se le hizo un armazón, pues todo un frame en acero inoxidable, para que estuviera pues fijo dentro del separador. Se hizo pues su descarga por gravedad. Se dirigió esta descarga a la tubería desnatadora, Y pues el resultado pues ya per se a la operación del equipo era pues que los porcentajes del BSW del fluido recolectado pues se redujo en un 50%. De esta manera pues nosotros digamos que el, complementamos pues la infraestructura, las facilidades que ya tenía nuestro cliente sin tener pues que incurrir pues en costos o en afectar su CAPEX, cambiando pues algún tipo de estructura o diciéndole pues simplemente que su tubería desnatadora ya era obsoleta o que no servía para nada, ¿no? Simplemente lo que hicimos fue complementar y optimizar pues el trabajo a la tubería desnatadora que ya tenían allí instalada. Obviamente pues ya el caso al ser un skimmer pues que trabaja 24/7 pues ya las horas hombre se redujo solamente a las horas de mantenimiento que se le hacen el equipo. Aproximadamente son dos mantenimientos al año. Siguiente, por favor. Este es otro caso en el que instalamos dos T14 con en puentes también. Lo que se requiere ya, este tipo de separadores ya tenían otro tipo de diferentes componentes en su fluido. Ya estábamos hablando de algunos aromáticos, ya estábamos hablando de algunos productos ya terciarios en los procesos en sus procesos de refinación. Continuaban pues con la recepción de algunos tanques de almacenamiento, algunos fluidos de almacenamiento de aceite lubricante, de aceite hidráulico y tenían pues el componente que había también presencia de nafta. Algunos solventes también como benceno, el etilbenceno y algunos silenos también se encontraban, pues tenían ahí en este separador. El problema que tenían es pues que el separador no estaba siendo óptimo en sus descargas de aceite y pues lo que hacía era que estaba teniendo alguna especie de leak o se estaba pasando algo de este fluido a un río que tenían ahí cercano. Entonces pues es bastante compleja el escenario. Siguiente, por favor. Lo que hicimos fue, digamos que lo que se aprovechó pues con el cliente es que nos dice o nos requiere que el porcentaje de agua o el BSW no puede ser mayor al 20%. Y no puede tener también de tener máximo pues un 15% de partes por millón para el crudo en sus descargas. Entonces lo que hacemos es recomendar este par de skimmers, los T14. Ellos pues, se arma toda una infraestructura de tipo puente para que estén fijos ahí en el separador y se le instala también unos bombas de cabezales. Estos, pues, los resultados que se obtienen, pues es una operación continua. Ya ese problema que tenía el cliente de pasarse el fluido a este río, pues se redujo porque pues también se le hizo algunos arreglos a las distancias, pues, y a los diámetros de las descargas de las tuberías que ellos tenían. Y adicionalmente a eso, pues no solamente estaban requiriendo que un BCW del 20%, sino que estaban entregándole el equipo un fluido recolectado con un BSW menor al 5%. Entonces, una concentración de crudo menor a 2 ppm. Entonces, pues resultó pues bastante eficiente el proceso. Estos equipos pues aún están funcionando y pues el mantenimiento pues que se puede hacer de manera, todo este sistema de anclaje y de puente pues tiene los accesos para hacer los respectivos mantenimientos. Siguiente, por favor. Este otro caso es un T14, es la instalación de un T14 también en una estructura de puente on-board, ya con una bomba pues instalada dentro de su frame. Este separador pues tiene algo de crudo, tiene algunos productos ligeros y pues tiene algunas presencias de benceno y etilbenceno. ¿Cuál es el problema? Pues que digamos que toda la tubería no estaba haciendo lo suficiente para poder recolectar todo el aceite pues, que estaban teniendo y pues estaban obteniendo pues por lo menos un BSW del 80% que es bastante alto. Necesitaban también reducir pues sus tiempos de operador y pues esto lo ocasionaba con estos problemas y esta baja eficiencia pues de las tuberías. Pues tenían que realmente intervenir, invertir varias horas, hombre, interviniendo las líneas para poder por lo menos mantener ese BSW en el 80%. Siguiente, por favor. Los objetivos pues, del cliente en este momento pues, nos solicita pues, que no puede continuar pues, con las horas hombre pues, de intervención en estos sistemas que ya tenían allí instalados y los skimmers pues necesitan descargar en las tuberías desnatadoras directamente y por tal razón estos skimmers se les instala, por eso es los onboard pump, se les instalan las bombas de descarga para dirigir todo el fluido recolectado hacia las líneas de descarga de las instalaciones que ya tenían ahí ya preinstaladas. Se les hizo también un mantenimiento y pues ya pues digamos que se ajustó toda la línea de fluido para no perder pues la contención de todo el fluido recolectado. Y pues su mayor problema de un porcentaje de agua del 80%, pues se redujo a un porcentaje de agua del 5% ya con la operación de estos dos skimmers. Siguiente, por favor. Muchas gracias.
Okay, is it back to me? Right. Okay.
Yes, sir. Go ahead, please.
So this is the I believe the last batch of skimmers that we will focus on, or the last area of separation within petrochemical plants that we focus on, or we will focus on, and it's what we call in-tank skimmers. So I believe I've been very kind to Hader on this one, and I've not given him any case studies, although they do exist. And if this particular type of skimmer is of interest, then please let me know, or let the guys know. We can certainly provide case studies and more information. So in-tank skimmers is a term we use to describe where oil-water separation is required from a sealed tank, so a tank that is completely lined but enclosed with a roof as well. The same process happens with inside. The oil and water will separate, but when the oil gets to the surface, obviously it forms a layer and then needs to be removed. The reason in-tank skimmers are different is because the vapors, the volatile gases, have nowhere to escape to. They cannot escape to the environment, and that in turn creates a more volatile environment for the skimmer to be situated. So if we can move on to the next slide, please, Karen. Okay, a classic example of a tank farm or a storage facility within a petrochemical plant. So You can obviously store large volumes of hydrocarbons within these tanks, and periodically the tanks are cleaned, generally using high pressure jets to stop old oil from decaying or contaminating the internal surfaces. When they are sprayed with high pressure jets, it is relatively low volumes of water but high pressure, and that cleaning water then is taken away with the pumped away with the contaminated oil into a smaller tank, which is then separated. So tank cleaning water is something that needs to be separated so that that water can be recirculated, used more than once, and the oil is removed from that, so that the tanks aren't being cleaned with dirty water. Next slide, please. Okay, so the skimmer for these applications does look very different. It is not a disc skimmer because I mentioned the tanks are enclosed, so the area of operation is much more hazardous. So, for example, if you were talking about ATEX zones, that would be the difference between ATEX Zone 1 and something that is ATEX Zone 0. Zone 0, very highly volatile. The skimmer that is to be used must be intrinsically safe for that area. So this is not a selective disc skimmer, but this is a adjustable weir skimmer. So it relies on that overflow technique of the oil flowing over the lip. However, this skimmer does have a very accurate overflow level. Next slide, please. We might see. Okay, so the central part of the skimmer that you can see, this is actually being tested because you can see it. Normally these things live inside the dark tanks and they never see the light of day. But you can see this is flowing over only a few millimeters of the top surface of the liquid. Imagine the larger that overflow lip, if that was to be not a few millimeters, but say 15 millimeters, 10, 15 millimeters, then the chances are more water will overflow into that skimmer and the separation will not be as accurate. So this skimmer has a floating lip to reduce the thickness that it takes, but importantly, it is designed to remain inside the enclosed tanks, and there is no moving metal on metal parts, so no risk of sparks, no risk of static. I believe some of the photos shortly will also show the system when it's being manufactured, so it's not covered by the water and the oil, so you can get a better view. So next slide, please, Karen. Thank you. So this is a classic example. We saw earlier on the very large oil storage tanks, and to the side of those tanks you would have a smaller wastewater, cleaning water storage tanks, where the high pressure jets would feed from these water tanks, clean the large oil tanks periodically, and then the wastewater, the dirty water, would be returned here for settling, for skimming, processing, and then potentially reuse. Next slide, please. Okay, so inside of these tanks, we have the very small, but you can see it, floating skimmer at the waterline. But these tanks have a huge variation in their low liquid level and high liquid level lines. So there are two types that we can have: an articulated arm, as we see here, or a flexible pipe that goes from the skimmer to the outlet at the base. Personally, and our expertise shows as well, that The flexible pipes are nowhere near as effective as the specifically designed articulated arms. So the articulated arms, because of the metal work involved, they cost more at the original purchase time. However, they require much less service and maintenance. The pipes are not consumable. They have a 10-year plus lifespan, and that original outlay of cost at the start is covered with only years of years less service maintenance. That price is covered. We have developed these an awful lot recently, so you'll see on the sections of articulated arm there are stands, so that at the low liquid level, when the tank is drained, the pipe work will rest on the floor so that it does not get snagged or caught, and the system is is designed for its low level storage as well as full level operation. Next slide, please. And you can see we had a single hinged articulated arm in this image, a double hinged articulated arm in the previous, and next to the skimmer floating at the top, you will see there is a flotation unit. So that takes the flotation of the arm itself. That allows the skimmer to remain perfectly level on the surface of the water, so that the oil has an even flow into the skimmer's lip. Installation of these systems is very simple. I will go, if we go to the next slide, hopefully we'll see some photos of the units within the factory. This is our factory in the UK. And you'll see here that the skimmer is there on the table. All of this system is designed to go inside of one of those storage tanks. So firstly, it is all detachable. The skimmer can be broken down so that every item can be lowered through the staff access hatch of the tank. So there's no worries of one of these systems going from the UK to South America and not being physically able to go inside of the tank. They are all they can be broken down into smaller parts and then simply reassembled inside of the storage, inside of the frame tank. You have the floats here. You've got the gaskets, the moving, the purge welded joints, and this is the system being laid out for one of its factory acceptance tests by Saudi Aramco. Next slide, please. Okay, so a simple data sheet for an example of a in-tank skimmer, but much like I said with the T-disc skimmers earlier on, the selective disc skimmers, these are examples. If your tanks are shorter but wider, or taller and thinner, then by simply sharing the GA drawing of the tank and with the engineering team at Vicoma, and then sharing the chemical composition of the fluid that is inside, essentially all of the design work and the specifications can be put together so that the package can be provided. Next slide, please. So, like I said, the skimming systems can be ATEX, they can be zone 0, 1 or 2, or class 1, 0, 1, 2. It depends on the country specific requirements. So our friends in the United States generally use class. I say generally, but other parts of the world adopt the European method of ATEX. And there are some parts of the world that have their own international standard, their own standard that they use. Essentially, we've got lots and lots of experience at converting between the styles of standards so that the documentation package matches that the customers need. Next slide, please. Okay, so this isn't just the in-tank skimmers, this goes across the disc skimmers as well, but it's very, very important, and all of the process engineers who are used to dealing with these facilities will appreciate this, that the equipment is tested and badged with its site safety hazardous operating badges, and all of the documentation packs are provided to the customer, but also stored internationally in the CIRA international database. So this is a worst case scenario. If we provide a skimming system to a petrochemical facility, and then a few years later there is an incident at that facility, whoever purchased this equipment will be able to access the safety documents to show it was built to the correct standards and it was not this piece of equipment that caused the incident. Sometimes the documentation is just as important as the equipment itself. Next slide, please. Also probably covers gas certificates, yeah, gas markings, also all covered by the engineering and documentation package. So it's not, this isn't required when people buy a marine skimmer for an oil spill, but any specialist equipment into a petrochemical facility, these kind of badges, this documentation, it needs to be done to protect the operators, the facility, and the people that have invested in the equipment as well. Next slide, please. So the engineering and documentation package, and Vicoma have manufactured industrial skimmers for many, many years now. I didn't say this earlier, but I think it's worth pointing out that Vicoma are listed as the preferred and approved and preferred vendor for all industrial skimmers for Saudi Aramco, who are, as we know, the largest refining company in the world. So not just for the refineries in Saudi Arabia, but you know, wherever Aramco are refining, if they have API separators, CPI separators, or outdoor settling ponds, pits, legacy pits, they will go out to tender for people to supply the separators, but they will say the separators need to come with the Vicoma disc skimmers. Likewise, if they take over any refineries, if they purchase a existing petrochemical facility, then they will purchase the equipment to overhaul and upgrade the systems using the skimmers. So it's a great list to be at the top of, but with that responsibility comes huge requirements. So for example, in the engineering and documentation packages, you know, we will have to prove things like the material identification, the weld strengths, the paint thickness, the system recovery rates, the safety features. Everything needs to be tested and proven to a very, very strict level. But that is something we've done for many, many years now, and it's something that we can easily replicate for other customers. Not everybody has such a high requirement on the documentation package. So if your documentation package is slightly more simple and less onerous as Saudi Aramco, then great, it's reflected in the amount of hours engineering, and it doesn't cost as much, basically. Next slide, please. So we're going back to where we started, really. The benefits of using these systems as an add-on, as an upgrade, a retrofit to an old petrochemical facility. So large cost savings over the lifetime of the period of the equipment, which can last for, well, I say 10 years, closer to 20. You know, they have very little maintenance and service requirements, and they recover an awful lot of oil. So the oil can be reused because it's such high quality, yeah, the systems can be left unattended. The systems are set up to the site safety matrix. So we have the VFD, which connects to the control room. So essentially the operator in the control room can see if the system has shut itself down because of a safety risk, and that's when they can send somebody to check. It doesn't just continue working until a person physically spots a problem, because often that would be too late. So yeah, we've said highly efficient and minimum downtime. It's a very quick investment payback if you look at the price of the high quality oil it has recovered compared to the lower price for the oil water mixture that the unselective methods choose. And I believe, as Hade may have mentioned, because I did see some of the different oil types and chemical types in his case studies. Some of these are in crude oil facilities. Some of them are dealing with the much more volatile ends, the naphthas, the kerosenes, things like that. So it can cover a large range of hydrocarbons. Next slide, please. So the separators can be retrofitted, 24/7 operation, and it's a proven solution. So we've been making them for, I believe, over 30 years now. It does reduce the air pollution continuously, removing the pollutant. I've been to some refineries in South America where people have, housing has moved closer and closer to the refinery. With housing comes schools, comes, shopping centres, and this just takes rid of the vapours in a much quicker, controlled manner. And like I say, long design lifespan of easily over 10 years. Next slide, please. So some of the benefits here for you guys to take away with you. We've talked most of them, and they're just some schematics to show about the C pipes and the skimming into a C pipe. Next slide, please. Hey, and I can't remember that photo being taken, but yeah, okay. If you have any questions, then we'd be more than happy to answer them. And thank you very much for your time.
Thank you to you, Peter. We have one question here, and it says how to control uniform flow and turbulence conditions in the APIs.
So, sorry, how to control the flow?
How to control uniform flow and turbulence conditions.
Okay.
In the API and CPI.
Yeah. Well, the turbulence. So we talked about the floating skimmers at the start in ponds and pits. And if the API separators have a variable liquid height, then we would always offer a floating type skimmer. So the skimmer would always remain on the surface, and therefore the discs would always interact with the oil water interface. The flow rate, these are variable flow rate skimmers. So for example, if you have a very high oil input into the separator, the disk speed is variable. It gets set to match the oil water intake on the separator. If the oil rate of entry to the separator varies, then we also can adopt, and we do this quite often, various sensors. So for example, an oil water interface sensor will tell the skimmer if there has been a sudden influx of oil, the skimmer will need to speed up to remove that oil. When that oil layer is removed, the sensor would detect that and tell the discs to slow down, so that because there is less oil to be recovered. So these sensors are very simple things to incorporate into the system. And yeah, I think regarding turbulence, within the separators, the turbulence is not really a huge problem. You might experience small ripples and, not so much waves, but small ripples and turbulence on the surface. But essentially, the vertical plane of the disc will pick up oil all through its vertical surface. So if the waves or ripples do rise up and down through turbulence of the water coming in or through any wind action on the surface of the separator, the oil is still captured by the vertical disc. I hope that answered the question.
Sure, absolutely. And for the last thing that we have Jaime. Jaime is the CEO of Barricade of Colombia. He's a petroleum engineer specialist in natural resource management, environmental and disaster prevention, and is manager in general management program with extensive experience in environmental and risk management projects from oil and gas industry. He has more than 25 years of experience, and it's our CEO. Ingeniero Jaime.
Hola Karen, buenos días todavía. Buenos días para todos. Nuevamente muchas gracias a todos ustedes por la asistencia, los que participaron en toda la presentación y los que nos compartieron algunos de los momentos. Pues realmente esta es una de las presentaciones que queríamos hacer debido a que de una u otra manera los skimmers o los equipos de desnatado se habían clasificado únicamente para las emergencias por derrames de hidrocarburos tanto nearshore, offshore y onshore. Sin embargo, con Bicoma pues se han desarrollado este tipo de soluciones, las cuales nos generan no solamente una posibilidad de hacerlas en instalaciones permanentes, sino son materiales que resisten la agresividad que tienen las aguas o los residuos que se producen en la industria petroquímica, y adicionalmente conservando todos los estándares de seguridad en lo que tiene que ver con explosion proof y en lo que tiene que ver con evitar que el personal se acerque mucho a estas áreas por la cantidad de vapores, la cantidad de contaminación que existe, y generando así una solución muy importante dentro de todos dentro de todas las necesidades que se tienen en este tipo de instalaciones. Entonces, para nosotros ha sido un placer haberles presentado esto. Adicionalmente, uno de los beneficios que, si bien es cierto de muchos de los que mostraron, acá hay un beneficio bien importante adicional, es que hoy día la recuperación de hidrocarburos se ha convertido en un target muy importante dentro de todas las instalaciones, llámese de refinación, llámese de petroquímica o llámese campos de producción, debido a que este tipo de hidrocarburo hoy día se recuperado con un BSW bajo puede o reincorporarse a un proceso o definitivamente buscar empresas que están trabajando en comprar o recuperar este tipo de residuo, mezclarlo y hacer unos subproductos que antes no se tenían en cuenta. Hoy día sí se están comercializando. Entonces, esto era lo que le queríamos comentar a todos ustedes, agradeciendo su participación, como les comentó Karen, sus emails, su información, es muy importante para nosotros, su información de contacto, para poderles enviar la presentación en español, la presentación en inglés, y seguir en contacto con todos ustedes para el siguiente Knowledge Experience, que también va a ser una sorpresa interesante para la industria petrolera y petroquímica. Y bueno, agradecer a Karen, a Hader. Thank you so much, Peter, for your presentation. They are very exciting and very good equipments and very good technical description. Para todos, muchas gracias, muy amables, que tengan un excelente resto de día. Por favor, cuídense mucho, todos estamos sufriendo de este fenómeno de la pandemia y esperamos que las familias y los asistentes se estén cuidando muchísimo y que ojalá salgamos adelante de esta situación, y esperamos poderles servir no solamente con Bicoma como nuestra representación para Colombia y algunos países de Latinoamérica, sino también con todos los servicios que tiene Orichem de Colombia a disposición para todos y cada uno de ustedes. Muchas gracias y que tengan un excelente resto de tarde y buen fin de semana.
Gracias a todos por su asistencia. Esperamos tenerlos en nuestros próximos eventos y quedamos pendientes. Yo les estaré enviando a cada uno de ustedes el certificado de participación de este tercer Knowledge Experience. Peter, thank you so much again, and thank you, Baricam team, for your help.
Excellent.
Take care.